ears to feel pain. Her throat was feeling pain. Your ENT systems, your ear, nose, and throat are all connected on the inside of your body. Okay? So you were feeling pressure in here. Your nerves could not handle it. It was hurting in everything. Yeah. That doesn't happen to everyone, but it does happen. Well, Ms. Brown, what about those fighter pilots and all those folks who fly all day, every day? They're used to it. They know what happens. If they have a condition as severe as hers, they'll either find a way to deal with it or stop flying.
I was tripping. It was hurt.
Okay? Pilots in those combat aircraft, they go up real fast and they'll go through 2 or 3 pressure zones very quickly. They learn how to deal with that and control their ears so that it does not pop on them. But the pressure changes for every single person. Well, Mr. Brown, what about if I'm underwater? Same thing. Same thing.
When I was in California, we drove to Vegas, like when we was riding through the mountains, we did the same type of thing.
Sure.
Same thing.
Okay. Driving hundreds of feet change is way different than just 20 feet, 30 feet. Because we go up and down hills all over the place, you're right. But that's just 10, 20 feet, no big deal. If your body pressure is normal for that 10 or 20 foot change, you're good. There are fish and creatures in the ocean that live within their aquatic zone. There are 3 primary aquatic zones in the ocean: surface, mid-range, and subsurface. And when I talk about subsurface, I'm talking about it's what's known as the midnight zone for oceanographers. It's so deep, it's dark, it's cool, the sunlight does not reach that depth of the ocean. Those organisms cannot live in the upper surfaces.
47 meters down, and she was like, the girl told her like if they swam up to the top just straight in the middle, they'd get
the bends.
Yeah.
Okay. The bends is a process where your body is changing pressure, and your body is so sensitive it can recognize the pressure change in your feet, your arms, your hands, everything. Not just your ears, but our ears are most sensitive for it, because that's what we feel. The air pressure is right there. Well, I'm diving. I'm under the ocean. I'm 47 meters down. I'm coming up. If I come too fast without pausing, my body does not have opportunity to process that change and get adjusted to it. The bend is a condition where you have oxidation that goes on. The nitrous, well, it produces nitrogen bubbles in your bloodstream.
Everywhere?
Everywhere.
See,
and you can't control those. So if you rise too quickly and that nitrogen does not have a chance to dissipate in your bloodstream, it causes massive pain all over your body. And so they bring you up, they put you in a decompression chamber, and they take you back down to the depth of the 47 meters and bring you up very, very slowly to allow that nitrogen to get out of your bloodstream. Because if not, you're in pain, it hurts. Okay? So let's look at this. That's pressure underwater. The airplane is pressure up above. You're riding in the car or up and down those big mountains is pressure on your body in a car. Here, we're going to take the simple pressure in this room. And right now I have some water that's just in this container.
He gonna put it in there and
I flagged it.
I know this.
Thank you.
My bad.
We're going to take this water. We actually heat the water. With the water being heated, it expands. It expands and it forces all of the oxygen that is in the can or the air out, and it is replaced with water vapor. What happens if I take that water vapor and cool it down very quickly? I'm about to throw something at you. Yes, ma'am.
You don't know how to, I already know, so.
Go ahead. I'll thank you.
It crushes the can.
Why does it crush the can? That's the question.
Because pressure change so quickly.
Did the pressure change on the outside of the can?
Yeah.
Did
I
it?
think it's the inside. It's not.
Did it?
I don't know.
You said yeah. Y'all tell me.
Nah, it's the same on the outside, but it's different on the inside.
Ah, it's different on the inside. And why did it change on the inside?
I don't know.
Don't remember?
I don't know.
Don't remember.
I don't remember either.
Okay? We're going to take this one. Yes, we did. All right, let's see what happens. Okay? It pulled, okay? It collapsed the can some, all right? Not all the way. Let's see if I can get another one. All right. There you go. Okay. Quickly changing the temperature on the inside of the can. What happened to that water vapor on the inside of the can?
It changed. It disappeared. I mean,
Did it disappear?
It evaporated. Ain't that the word?
Condense.
Yeah.
Condense, thank you.
You know.
Jimmy! Okay, and so it condenses. When it condenses, it pulls down and shrinks down really close. The water vapor itself. Well, when that happened so quickly that it had no place else to get any distance from or capacity, it pulls in on that can. Well, let's go look at something else. We're heating small amounts of water in the bottom of this barrel. It pushes all of the oxygen out, and that entire barrel is filled with water vapor. You can see it because it's trying to escape. In order to expedite this experiment, they're actually going to show and seal that top of that barrel. I wouldn't seal it the way that they did because it's still hot. But let's see if I can move up here a little bit more. Okay? They're actually sealing it.
That's fine.
Okay? After sealing it, the barrel is still too hot to the touch. So they use some lumber. They're going to cool the barrel down by placing it in a baby pool of ice. Why?
Patience.
Well, I mean, talk to me. I mean,
It didn't do it.
It did.
No, it's taking time. But they
Why?
need to
So-
go through it. They need to move.
Because it's big, so yeah.
Okay, it is larger. Okay.
Yeah.
Now, mind you, this is a little baby pool, has ice in it. Okay. It does not appear to be happening instantly. Well, gee. Okay. But what's going on inside that barrel?
Oh, it's working. I mean, it's condensing.
It's condensing. It's beginning to pull in on it. It is actually changing the temperature of the water or remaining water vapor inside the barrel. Well, think about it. This is a big old super heavy duty steel, a galvanized steel barrel. Well, she's trying to, you know, rush it. Okay? Come on, I need this to happen right now. Okay? Okay? In that particular case, okay, she's still trying to make it happen. It's not happening fast enough for us. Well, we are impatient beings. Okay? So, well, you know, okay, let me help it. Now what happened?
Oh, I did it.
You blinked and you missed it. Okay? Fire along here. You need to see it again. Okay? Just helping the whole process cool down.
The camera.
Everybody jumps.